Assalamu alaikum dear students. My name is Ehsan Elahi. I'm here with a new video on YouTube channel which is about MOSFET, metal oxide silicon field effect transistor. Dear students, we have studied earlier about Jfet junction field effect transistor. We will study at this time about MOSFET metal oxide field effect transistor. Basically, metal oxide field effect transistor is a semiconductor device that is widely used for switching purpose and for the amplification of electronic signal in electronic devices. Through this MOSFET or through this device, we enhance the value of voltage or current through this device. And why we call it MOSFET? It has three types of material, or it consists of three types of material. First is metal, and the source and drain or in consist of metals. In this we use source and drain as a metal contacts in MOSFET, and for oxide silicon dioxide is used as insulating layer between channel and gate. And semiconductor, the basic structure on which N and P type region are diffused or whole material or whole schematic placed on silicon substrate, which is semiconductor material. There are two types of MOSFET. First is depletion type and second is enhancement type. In depletion type, the channel material is present, and in enhancement type, the channel material is absent. Here is a n-type D-MOSFET, which is depletion type MOSFET, and we can see the channel material is present between source and drain. And this is silicon dioxide layer, and the whole arrangement is placed on silicon substrate. We have choose here a bottom gate in this schematic diagram. This is the schematic diagram of D-MOSFET, which is called depletion type MOSFET, and this is the symbolic representation of n-channel MOSFET. It consists of four terminals. If we connect the substrate to the source, then we call it three-terminal device. And this is the schematic diagram of MOSFET, in which we used as a uh, gold as a metal contact, which is connected with chrome contact, and we have utilized here a metal contact which is gold. And these are the differences between JFET and MOSFET, because JFET gate is not insulated from the channel material, and MOSFET, also called IGFET, because it's in which channel is insulated from gate through silicon dioxide layer, and channel and gate forms two p-n junction, but channel in MOSFET channel and gate form parallel plate capacitor. There consist of a silicon dioxide layer between gate and a channel, and it acts as a dielectric medium. That's why we call it as a this arrangement as a capacitor. Jfet has three leads, but MOSFET also has three leads if we connect substrate to source. And JFET has high input impedance, but MOSFET has very high input impedance in the range of mega ohms. And JFET is difficult to fabricate, but MOSFET is very easy to fabricate, and signal handling capacity in a MOSFET uh, is so easy, and MOSFET easily available. Here is the schematic diagram of n-channel DMOSFET, in which we have applied the biasing, and we have applied here source drain voltage, and we can see that also we have applied here the gate to source voltage. This is the schematic diagram through we can see the whole arrangement, and this is the metal electrode which is gate, and this is metal oxide layer which is SiO2 layer. And this is the N channel. We choose some material for as a channel material, and this is the whole substrate, and this is N channel material, and the substrate is p type, because here silicon having trivalent impurity, and substrate is connected to the source, and the N channel is connected to the gate via thin insulating layer of SiO2, and a silicon insulated layer between N channel and gate channel, and gate is present. That's why MOSFET also called IGFT, insulated gate field effect transistor. When we apply biasing, the electrons go from source to drain, and due to positive polarity of drain, the electron goes from source to drain. And here is the schematic arrangement. We have applied drain to positive voltage and negative voltage to the source. Negative terminal is connected to the source. Electron travel from source to drain through this path, which is called channel, and the positive terminal attracts these electrons, and VGS value of VGS is 0 here. When we change the biasing and we enhance the value of VGS towards negative, when VGS set at negative voltage such as -1, when we apply the minus voltage or minus value of voltage to gate terminal, then number of electrons will be repelled, and the number of holes from substrate will be attracted towards the channel material, and electron hole recombination will occur here, and the value of source drain current will decrease. The negative potential at gate pressure electrons towards the p-type substrate and attract the holes for p-type substrate. The more negative VGS, the resulting level of drain current is reduced. When VGS is reduced to pinch of voltage, then the value of source drain current will be 0, because number of holes will be attracted from P substrate towards the channel, and electron hole recombination will occur here. That's why the number of electron will be decreased. This is the diagram about the transfer characteristics for n-channel depletion type MOSFET. In this diagram, we can see that when the value of VGS is 0, then we can see here 8 milliampere. For example, 8 milliampere, the value of maximum current or saturation drain to source current. When we apply the value of VGS is equal to -1, then the value of saturation current decreases, and so on. When we decreases the value of voltage or increases the value of voltage towards the negative side, and then the source drain current uh, decreases at this time, and at reaching pinch of voltage VGS is equal to -6, then the value of current IDS will be 0, and when we apply the value of VGS +1, then the source drain current will increase, and this graph is between the drain current and VGS voltage. And here there are two types of modes. Here is a depletion mode, which is uh, for negative voltages, and here is enhancement mode, which is for positive voltage when we have applied the VGS is +1. When VGS is reduced to VP, pinch of voltage, then the source drain current decreases and up and goes to 0. For positive value of VGS, the positive gate voltage will draw additional electrons, free charge carrier from p-type substrate, and hence ID increases. And these are the some characteristics are here, and these characteristics for Jfet: when VGS is equal to 0, ID is equal to 0. When VGS is less than 0 and IDS will be less than saturation current. And these are similar to the Jfet, and also these characteristics are also applicable for MOSFET. But here is a new characteristic for MOSFET. When VGS is greater than 0, then ID increases above the IDSS, and VGS, and we can see that VGS, polarity of VGS is positive here. And here is a, this is the symbol of p-type, p-channel depletion type MOSFET, and here is, it is the diagram, schematic diagram of p-channel MOSFET, in which we can see here the p-channel between source and drain, and substrate is used here is n-channel. The whole arrangement is similar to the n-type depletion type MOSFET, but the polarities of VGS and VDS will be reversed. Here are the some characteristics for p-channel depletion type MOSFET. We can see here when the value of VGS 0, then the IDSS is approximately is equal to 6 milliampere. But when we enhance the value of VGS positive, we can see here from here when we apply the positive value of uh, gate to source voltage, then the number of electron will be attracted towards the p region, and hole and electron recombination will occur, and the value of IDS will be decreases at this time. And here we can see that when we apply the value of VGS positive, then the source drain current decreases, and up to so on when we goes to VGS is equal to VP is equal to 6 voltage and positive 6, then the value of IDS will be 0, and we can say that uh, the MOSFET in non-functioning state. And when we decrease the value of voltage towards negative value, then the value of current increases, and there are two types of region: enhancement region here and depletion region here. And this is the lecture about MOSFET. We have studied here about metal oxide field effect transistor. We have studied here the two types of metal oxide field effect transistor, p type and n type. In n-type, we have discussed about the uh, value of voltage. When the VGS is positive, then the current will increases, and we will go to the enhancement region. And in p-type, there is a polarity difference. When VGS is equal to negative, then we will go to enhancement region, and the current increases. And this is the lecture about MOSFET. I hope you have understand. दुआओं में याद रखिएगा। अल्लाह हाफिज़।